Accurate counting can be a critical component of any industry. Without accurate counts, inventories cannot be maintained and profit-loss calculations cannot be made. We will first look at these push pins. How many are pictured here? It's not difficult to count when there are only one or two. Here, it's a little more difficult, but easily managed with few errors. What about now? How would you go about counting these push pins to make sure the right number goes into the container for sale? We could attempt to count them like this, but it would take too long. What if our product is more delicate than push pins? If there are only a few to count, like these two baby chicks, it's easy to avoid errors. What about now? If your job is to count a specific number of baby chicks for shipping, how would you do it without damaging them? Here they are counted by hand and quickly packaged in appropriate shipping containers. What if your job was to count 5,000 juvenile fish to stock a lake? How would you go about counting the fish without injuring them or taking too long? This video will demonstrate a method used by hatchery managers to quickly count large numbers of small, delicate juvenile fish while minimizing handling stress. This method will allow a hatchery manager to stock this lake accurately. Displacement is defined as the volume or weight of a fluid, such as water, displaced by a body, such as a stone or fish, of equal weight. We first will begin with an example, counting stones that are similar in size. We start with a beaker filled with 20 milliliters of water. We count stones into the 20 milliliters until the water level reads 25 milliliters. At this point, we record the number of stones in sample 1. In this example, 5 stones were needed to raise the water level to 25 milliliters. In other words, 5 stones will displace 5 milliliters. To calculate how many milliliters one stone will displace, we divide the number of milliliters displaced, 5, by the number of stones it took to displace them, also 5. In our example, 1 milliliter is displaced by 1 stone. Now we will fill a larger beaker with 1,000 milliliters. We add stones to the water until the level reads 5,000 milliliters. How many stones did we add? If 1 stone displaces 1 milliliter, we subtract our starting water level, 1,000 milliliters, from our ending water level, 5,000 milliliters. In our example, we displaced 4,000 milliliters with our stones. From our samples, we calculated that 1 milliliter is displaced by 1 stone. Therefore, 4,000 milliliters are displaced by 4,000 stones. This is a much more efficient method of counting large numbers of similarly sized things. Now, let's take this technique to the hatchery. In the hatchery manager will fill a graduated cylinder with 20 milliliters of water. Using a plastic spoon to handle the juvenile fish, the hatchery manager counts fish into the graduated cylinder, being careful not to add water. When the water level in the graduated cylinder reads 25 milliliters, the hatchery manager records the number of fish added. This process is repeated several times to allow for improved accuracy. In this example, the hatchery manager records 5 samples. With the 5 samples recorded, the average number of fish needed to displace 5 milliliters can be calculated. To calculate the average, we will add the number of fish in each of the samples taken and divide by the number of samples. You can see the formula here. Add all the fish in samples 1 through 5 and divide by 5. The number of fish in our samples adds up to 54. We have 5 total samples. 54 divided by 5 is 10.8. We have now determined that it takes 10.8 of our fish to displace 5 milliliters. Next, we calculate how many of our fish will displace 1 milliliter. We do this by dividing our 10.8 fish in 5 milliliters by 5. We now know that it takes 2.16 of our fish to displace 1 milliliter. How can you use what we have determined so far to count 5,000 fish to stock a lake? We can't count them like we did the pushpins or the chickens. Using what we calculated earlier, we can follow these steps and count 5,000 fish with reasonable accuracy. First, we know 2.16 fish will displace 1 milliliter. We need 5,000 fish to stock the lake. How many milliliters do we need to displace? We calculate this by dividing the number of fish we need, 5,000, by the number of fish needed to displace 1 milliliter, 2.16. We cancel our units and are left with 2,315 milliliters that are displaced by 5,000 fish. Back in the hatchery, the manager fills larger beakers with 4,000 milliliters of water. He then adds a larger number of our fish to the beakers, being careful not to add any water. As the fish are added, the water level increases. The hatchery manager checks the level, and as he gets closer to 5,000 milliliters, he will use a smaller net to add fewer fish up to the 5,000 milliliter mark. The whole process takes only a couple of minutes, during which the beaker is aerated with an air stone. The air stone is removed while the hatchery manager reads the water level to ensure accurate measuring. When the water level increases from 4,000 milliliters to 5,000 milliliters, the hatchery manager knows he has displaced 1,000 milliliters with fish. We know that 5,000 of our fish will displace 2,315 milliliters. Therefore, the process will be repeated again until the hatchery manager has counted the needed fish for stocking. To check our estimation, we can multiply the number of milliliters we displaced, 2,315, by the number of fish we need to displace 1 milliliter of water, 2.16. This counting exercise was completed in just a few minutes, making it fast and accurate while minimizing the handling of our fish.